Good afternoon, everyone. It's my pleasure to be here at the 26th Vietnamese Congress of Radiology and Nuclear Medicine. My name is Phạm Minh. I'm currently a radiology resident at Thái Nguyên University of Medicine and Pharmacy. Today, I'll be discussing about relationship between EGFR mutation and computed tomography features in patients with non-small cell lung cancer. As all of us know, according to Global Cancer Statistics 2022, lung cancer is the leading cause of cancer-related mortality in both men and women, with the number of deaths is almost 2 million and almost 2.5 million new cases. Lung cancer, according to the World Health Organization, is divided into two types: small cell lung cancer and non-small cell lung cancer, with the latter accounts for the majority of about 85%. Patients with non-small cell lung cancer are often diagnosed at advanced stages, which makes them lose the opportunity of surgery. As a consequence, their treatment options narrow down to chemotherapy or targeted therapy. Targeted therapy with EGFR TKIs has been proved to bring benefits to our patients. However, not every patient with non-small cell lung cancer can benefit from targeted therapy. Prognosis can only be improved in patients with EGFR mutation. Since EGFR mutation testing is expensive and in some cases it is difficult to obtain adequate tissue of the tumor, I wonder, should there be other ways to detect the gene mutation? And luckily, the answer is a yes. Our researchers have do several research, and those researchers show that the CT features have correlation with pathology subtypes, and the pathology, histology, or subtype have relationship with EGFR mutation. So predicting EGFR mutation by clinical and imaging features is important. Over the last decade in the world, there have been several studies about this issue. In Vietnam, until 2024, there has been only one researching the relationship between EGFR mutation and CT lung features. So we decided to conduct our study to investigate the relationship between EGFR mutation and CT features in patients with non-small cell lung cancer. In our study, 98 patients with non-small cell lung cancer from January 2023 to May 2025 at Thái Nguyên National Hospital who underwent HSCT followed by CT-guided biopsy and EGFR mutation testing were enrolled. Univariate and logistic regression analysis were performed to identify the independent risk factor relevant to EGFR gene mutation. Our CT image were interpreted by a researcher and a radiologist with over 5 years of experience. And this is the result of our study. In our study, there were 35 patients with EGFR mutation. This accounts for 35.7% of the total number, and this consists with previous study in Asian cohorts. Now let's take a look at Table 1, the clinical features relevant to EGFR mutation. As we all can see, the p-value of the first and the third factor is 0.007 and 0.028 respectively. This means that female and adenocarcinoma histological subtype could predict EGFR mutation. This consists with previous study. Moreover, now let's discuss about the CT image features. Since the predicting EGFR mutation by clinical features alone is inappropriate, and over the last 10 years, a lot of radiologists have been working to identify the EGFR mutation due to lung CT imaging feature, and they did find interesting information. So do we. In Table 2, we can see that the p-value of pleural retraction is less than 0.05. This is similar to previous study, and pleural retraction is a common sign of visceral pleural invasion. In table 3, halocyte has a p-value of 0.00. That is similar to Kurzweil study. Halocyte correlates with lipidic growth, which is common in bronchoalveolar carcinoma. And this type of histological pathology have relationship with EGFR mutation. And so the patients with these features can benefit from targeted therapy. The last imaging feature related to EGFR mutation in our study were pleural effusion with a p-value of 0.001. That is different from previous study. We do not find any correlation between lesion density, margin, air bronchogram, calcification, and lymphadenopathy. This difference may be due to the discrepancies in sample size and ethnicity. Now let's discuss about the independent factors related to EGFR gene mutation. Our figures were evaluated by logistic regression analysis. The results indicate that female gender, lung CD features of halocyte, pleural retraction, and pleural effusion were independent factors relevant to EGFR mutation. Figure 1 shows CD features in non-small cell lung cancer. From the left to the right, we have solid mass, spiculated margin, air bronchogram size, calcification, pleural retraction, halocyte, cavitation, lymphadenopathy, and the last one is pleural effusion. In conclusion, our study indicates that female patients with lung CD feature of halocyte, pleural retraction, and pleural effusion are more prone to harbor EGFR gene mutation. The clarification of the relationship between molecular markers and CD characteristics provides supporting evidence for potential molecular targets that may be treated using targeted drugs. We haven't yet focused on the relationship between specific EGFR subtypes like EGFR19F, exon deletion, or L858R, and CD imaging features. Each EGFR subtype may present different CD image, which needs further studies to investigate. These are my references, and this is the end of my presentation. Thank you for listening.
And thank you. And at the end of the slide, you talk about you need to further investigation to find out more the efficacy of this research. So what kind of study you want to do more in the future?
I mean, in the world, there have already been the researches about the relationship between EGFR subtypes with CD images. However, in Vietnam, we haven't that. In my study, if in the future I have the opportunity to conduct another study, I can do research about the EGFR subtype just by we read the EGFR mutation test report, and in that report they would answer the subtypes of this EGFR mutation, and then we would divide it. We would survey the relationship of specific kind of EGFR mutation, and I can just calculate the p-value of that, and I think we may have the relationship.